Yesterday we were discussing about the concept of centripetal force. Okay, we learned that for particle to perform circular motion, there must be a force acting on a particle along the radius towards the center of circle. This force is responsible for producing centripetal acceleration. This centripetal acceleration is responsible for changing the direction of velocity at every instant. Now, there is another force we are going to talk about, and that force is centrifugal force. What exactly is the word centrifugal force? Okay, yesterday we talked about centripetal force. See, when a particle performs uniform circular motion, we learn that this is an accelerated motion. Now let us imagine there is a large horizontal floor, and this large horizontal floor is rotating with uniform angular velocity omega. Okay, this is the axis of rotation about which this floor is rotating with uniform angular velocity omega. And there are, suppose you are standing on this floor. तुम्ही या फ्लोर वरती उभे आहात. Correct? Now, as this floor will start rotating, ही फ्लोर रोटेट व्हायला लागली की तुम्हाला असं जाणवेल की कुठला तरी फोर्स तुमच्यावरती ॲक्ट होतोय आणि तो फोर्स काय करतोय? इट इज ट्राईंग टू पुश यू आउटवर्ड्स. तो फोर्स तुम्हाला बाहेर ढकलतोय. ओके, अम्युजमेंट पार्कमध्ये किंवा मे बी काही गार्डन्समध्ये सुद्धा अशा प्रकारचे what they call this merry-go-round. Yeah, you must have experienced this type of force on merry-go-round. Correct? You must have experienced that. You get a feeling someone is pushing you out. Now you see that no one is in contact with you and you don't understand who is pushing you outward. Actually, why you get this feeling? Because when you see your motion, if there is another observer who is standing outside and looking at you, now for this observer your motion is circular motion. When you are on this platform, you are stationary with respect to platform, but for this observer you are performing which motion? Circular motion. Now to perform circular motion you will require which force? Centripetal force. Getting it? Actually that centripetal force is provided by friction between your feet and the ground. If this ground is frictionless, correct, there won't be any centripetal force available for your circular motion. There is this friction acting on you which is acting as a required centripetal force. So this person can explain which force, why you are getting a feeling that as if you are thrown out. Because if there is no centripetal force, obviously you will be thrown out of the circle. But when you are on this rotating turntable or rotating ground, you will not understand, because are you rotating with respect to this rotating table? No, you are stationary. Are you performing circular motion with reference to this ground? You are not performing any motion, you are stationary. But still there is some force which is pushing you outward. What is this force? Try to understand that when you are on the rotating ground, you are in non-inertial frame of reference. Which frame of reference? Non-inertial frame of reference. A rotating ground, okay, a ground which is performing this rotational motion, every point is in circular motion. Okay, circular motion is a accelerated motion. Circular motion is accelerated motion. What is the direction of acceleration? Along the radius towards the center of circle. In non-inertial frame of reference, Newton's laws of motion are not applicable. Hence, you cannot explain why you are getting a feeling as if you are getting pushed outward. तुम्हाला एक्सप्लेन नाही करता येत, कारण तुम्ही कुठल्या फ्रेम ऑफ रेफरन्स मध्ये आहात? नॉन इनर्शियल. जर तुम्हाला या नॉन इनर्शियल फ्रेम ऑफ रेफरन्स मध्ये राहून तुमची मोशन एक्सप्लेन करायची असेल तर काय केलं पाहिजे? You have to consider existence of imaginary force called as pseudo force. What should be the direction of the pseudo force? Opposite to acceleration of frame of reference. So if frame of reference is accelerated along the radius towards the center, the pseudo force acting on you should be along the radius directed away from the center. Getting it? When someone is observing you from outside, do this person have to consider this pseudo force? No. You have to consider pseudo force only when you are in non-inertial frame of reference. In order to make Newton's law applicable in non-inertial frame of reference, we have to consider this pseudo force. What will be the magnitude of this pseudo force? Mass of a body into acceleration of frame of reference. So what is acceleration of frame of reference? V square by R or V omega or omega square R. So the magnitude of this force is same as that of centripetal force. वेगळी आहे का magnitude या force ची? Same as that of centripetal force. But what is the direction? Direction is opposite to centripetal acceleration. या pseudo force ची direction कशी पाहिजे? Opposite to acceleration of frame of reference. So it is along the radius directed away from the circle. Along the radius directed away from the circle. This force, pseudo force in uniform circular motion is called as centrifugal force. So what is centrifugal force? It is a pseudo force that has to be considered in uniform circular motion because it is a non-inertial frame of reference. Pseudo force in UCM is given a special name called as centrifugal force. बरोबर आहे? So when you are in this non-inertial frame of reference which is performing UCM, which force is acting on you? Centrifugal force is acting on you, which is trying to push you out of the circle, away from the center of the circle. Can we give some examples of this centrifugal force from our day-to-day life? Okay, let me give you one very simple example. You must have done this experiment many times. See, if we take a glass full of water, ओके, पाण्यानं भरलेला ग्लास हातामध्ये घेतला, and if we rotate this glass in a vertical circle at sufficiently high speed, what do you find? The water does not spill. त्या ग्लासमधलं पाणी खाली सांडत नाही. Actually, what happens there? See, at the topmost position, even though the glass is like this, okay, it is performing which motion? Circular motion. Even at the topmost position, the water doesn't spill down. Getting it? Why this is so? Why water is not falling? If the glass would have been stationary, water would have been definitely fell down. Agree or not? What happens if this glass is performing circular motion? If the glass is performing circular motion, my water is in non-inertial frame of reference. If the glass would have been stationary, the only force acting would have been self-weight and water would have fall down. Because of the circular motion of the glass, water is in which frame of reference? Non-inertial frame of reference. So there is force acting on the glass along the radius away from the center, which is in which direction? Vertical direction. Because of this force, what will happen? This force, centrifugal force, will balance the self weight. This force will balance the self weight and hence water will not spill. पाणी खाली पडणार नाही. ॲग्री विथ दिस? किती असतो हा सेंट्रिफ्युगल फोर्स मॅग्निट्यूड मध्ये? सेम ॲज दॅट ऑफ सेंट्रिपिटल फोर्स, म्हणजे mv²/r. जर पाणी खाली पडायला नको असेल, हा सेंट्रिपिटल फोर्स कसा पाहिजे? सेल्फ वेट पेक्षा जास्त पाहिजे किंवा ॲटलिस्ट इक्वल पाहिजे. बरोबर आहे? सो अंडर लिमिटिंग केस व्हॉट शुड हॅपन? दिस mv²/r शुड बी ग्रेटर दॅन इक्वल टू mg. इफ आय कॅन्सल दिस mm, v² should be greater than rg, or v should be greater than or equal to √rg. What does it means? It means that if the speed of the glass at topmost position is greater than √rg, r is a radius of circle, g is gravitational acceleration, water will not spill. If the speed is less than that, then the water will fall down. So if you take a glass full of water and rotate it very slowly, then water will fall down. But if your speed is greater than √rg, then what will happen? The water will not fall down. Correct? This is an example of what? Centrifugal force. Your mother must be separating cream from the milk. ओके, हाऊ द क्रीम सेपरेटर वर्क्स? घरामध्ये आपल्या ती रवी असते. ओके, ते आपण काय करतो, त्यांनी काय शब्द वापरतो? त्याला मराठीमध्ये छान शब्द आहे, घुसळवतो ते. बरोबर आहे? हॅव यू हर्ड दिस? आज ऐकलं, असं केलं तरी काय हरकत नाही. ओके, ते ताक घुसळवतो आपण. म्हणजे काय करतो रे? ॲक्च्युली वी गिव्ह दॅट अ सर्क्युलर मोशन. विच मोशन? सर्क्युलर मोशन. सो ते बटरचे जे पार्टिकल्स असतात, ओके, वन्स दॅट कर्ड स्टार्ट्स परफॉर्मिंग सर्क्युलर मोशन, दोज पार्टिकल्स ऑफ बटर आर इन विच फ्रेम ऑफ रेफरन्स? नॉन इनर्शियल फ्रेम ऑफ रेफरन्स. सो pseudo force, centrifugal force will act on them. In which direction this centrifugal force will act? Along the radius, away from the center. ओके, सो रवीनं असं ते घुसळवायला चालू केलं. What will happen? The centrifugal force will be acting along the radius away from the center, आणि ते जे बटरचे पार्टिकल्स आहेत ते काय होतात? सेपरेट आउट होतात. ओके, लोणी वेगळं होतं अशा पद्धतीनं. ओके, सो दिस ऑल्सो वन ऑफ द एक्झाम्पल ऑफ सेंट्रिफ्युगल फोर्स. ड्रायर ऑफ अ वॉशिंग मशीन. ओके, डू यू नो हाऊ द ड्रायर ऑफ अ वॉशिंग मशीन वर्क्स? Dryer of a washing machine has this heavy big cylindrical portion, okay, and this cylindrical portion has holes. It is perforated. It has holes from all sides. Correct? Whatever clothes are, you fit these clothes here. वरतून झाकण लावतो आपण, आणि तो ड्रायर ऑन केला की तो ड्रायर हाय वेलॉसिटीने काय होतो? रोटेट होतो, स्पिन होतो. तो ड्रायर स्पिन झाला की काय होतं? इट स्टार्ट्स परफॉर्मिंग, एव्हरी पार्टिकल स्टार्ट्स परफॉर्मिंग सर्क्युलर मोशन. त्या कपड्यांमधलं जे वॉटरचे पार्टिकल्स आहेत, दे ऑल्सो स्टार्ट्स परफॉर्मिंग सर्क्युलर मोशन. दे आर इन विच फ्रेम ऑफ रेफरन्स? नॉन इनर्शियल. सो सेंट्रिफ्युगल फोर्स विल ॲक्ट ऑन देम अँड दे विल गेट सेपरेटेड इन आउटवर्ड डायरेक्शन. ते बाहेर फेकले जातील, आणि हे जे होल्स आहेत साईडला, त्याच्यामधनं ते वॉटर पार्टिकल्स काय होतात? बाहेर पडतात. Getting it? So dryer of a washing machine also works on which principle? Centrifugal force. Bulging of earth at equator and flattening on poles. Earth is not exactly spherical. आपली पृथ्वी अशी छान स्पेरिकल नाहीये. तर पोल्सला, म्हणजे ज्या ॲक्सिसला ती रोटेट होते, याला आपण काय म्हणतो? पोल्स. ॲक्च्युअल आकार कसा आहे अर्थचा? It is flattened at poles, means असा काहीसा आकार आहे, म्हणजे इतका फ्लॅट नाहीये पण आयडिया यावी म्हणून. It has flattened at poles and bulged at equator. Why? Initially, when Earth was cooling, okay, it was in semi-solid state. So when it was in rotational motion, what would have happened? Because of the centrifugal force, the particles of that fluid are moving away from the axis of rotation, and because of that, earth is flat on the poles and bulked at the equator. This is also because of centrifugal force. If this is a rotating fan and if I put a small piece of rubber, okay, तुमचं खोड रबर तुम्ही जर त्या ब्लेड वरती ठेवलं, what will happen? Will it stay there? It will be thrown out. By which force? Centrifugal force. Actually, with respect to fan, it is thrown out. So when I explain it with respect to fan, I will say because of centrifugal force. But if I want to talk from the point of view of observer, मी त्याला खाली उभं राहून छानपैकी बघतोय, मी आहे का नॉन इनर्शियल फ्रेम मध्ये? मी कसं म्हटलं पाहिजे? त्या रबरला नेसेसरी सेंट्रिपिटल फोर्स मिळाला नाही म्हणून ते बाहेर पडलं, बरोबर आहे. आणि फॅन्सच्या रेफरन्सनं फॅन पासून दूर का गेलं? फॅन फ्रेम ऑफ रेफरन्सचा विचार करता काय बोललं पाहिजे? बिकॉज it is a non-inertial frame of reference, there is a centrifugal force acting on the rubber. Agree with this? So try to understand this concept of centrifugal force is only used when I am talking about the motion in non-inertial frame of reference. Agree with this? When motion is described with respect to non-inertial frame of reference. All of you understood this? Clearly कळतंय सगळ्यांना? झेपलंय सगळ्यांना? So this is all about centrifugal force. Is it a real force? It is a pseudo force, it is a imaginary force. Agree with this? How we will differentiate between centripetal and centrifugal force? A first point has to be centripetal is a real force, centrifugal is a imaginary force. Second point, centripetal force is directed along the radius towards the center of circle. Centrifugal force is directed along the radius away from the center of circle. Centripetal force is necessary for performing circular motion. No centripetal force, no circular motion. Centrifugal force has to be considered in order to explain the motion in non-inertial frame of reference. Understood this? So these are the point of differences between centripetal force and centrifugal force. I hope all of you understood this. नक्की कळालंय सगळ्यांना? बरं. आता होमवर्कला क्वेश्चन घ्या एक. Distinguish between centripetal and centrifugal force. Distinguish between centripetal and centrifugal force. And the second question, define centrifugal force. Define centrifugal force. Express it in vector form. Express it in vector form. And give any 4 examples examples of centrifugal force. Four examples किंवा 4 applications किंवा 4 consequences, कसंही प्रश्न आला तरी उत्तर सेम आहे. वेक्टर फॉर्म मध्ये कसं रिप्रेझेंट करणार सेंट्रिफ्युगल फोर्स? बघा, सी, if my particle is performing circular motion with constant angular velocity omega in anti-clockwise sense, suppose this is the center of circle, this is the position of particle. What is linear velocity? Tangential. Agree with this? What is radius vector? This is radius vector. What is the direction of centripetal force? Along the radius towards the center. Let me call this as FCP. This is centripetal force. What is centrifugal force? What is the direction? This is centrifugal force. Along the radius directed away from the center. Correct? What is angular velocity direction? Axial vector. Drawn like this. Agree or not? How I will represent centrifugal force in vector form? M omega square r. Now the direction of radius vector and centrifugal force are same. Correct? Centripetal होता तेव्हा इथे काय साइन दिली होती? मायनस साइन. आठवते सगळ्यांना? सेंट्रीफ्युगल फोर्सच्या बाबतीत रेडियस वेक्टर अँड सेंट्रीफ्युगल फोर्स दे आर इन सेम डायरेक्शन, दे आर पॅरलल. एग्री ऑर नॉट? ठीक आहे, जायचं पुढे. समजलं सगळ्यांना? ओके. नाउ नेक्स्ट इज a very important article from circular motion, and that is relationship between linear and angular acceleration. What we are going to talk about? Relationship between linear and angular acceleration. First of all, we will talk about this relationship in scalar form. See, in scalar form, linear velocity and angular velocity are related like this. So if I differentiate this with respect to t, what will happen? dv by dt is equal to d by dt r omega. Correct? dv by dt is rate of change of linear velocity with respect to time. So this is acceleration. Radius is constant. d omega by dt. What is d omega by dt? Rate of change of angular velocity with respect to time. So this is alpha. So linear acceleration is r into angular acceleration. What is the relationship? Linear acceleration in scalar form, linear acceleration is r into alpha. What is alpha? Angular acceleration. Clear with this? Okay. The more important relationship which I am going to find out is in vector form. Okay, let's discuss about this. मला सांगा, linear velocity, angular velocity and radius vector या तिघांमध्ये काय रिलेशनशिप आहे? Okay, who will tell me what is the correct relationship? Yes, V is equal to R cross omega or omega cross R. What is the correct? Omega cross r. R cross omega will be wrong. What is the correct relationship? Omega bar cross r bar. Agree with this? What is the correct? Omega cross r. आठवते सगळ्यांना? बरं. Now let me differentiate this with respect to t. What will happen? dv by dt. Correct? आता इथं या r ला कॉन्स्टंट ट्रीट करून चालणार नाही. r हा वेक्टर क्वांटिटी आहे. कशी क्वांटिटी आहे? वेक्टर. समोर लक्ष द्या सगळ्यांनी. पार्टिकल यूसीएम परफॉर्म करतो त्यावेळेस रेडियस वेक्टर कॉन्स्टंट राहते का? मॅग्निट्यूड रिमेन्स कॉन्स्टंट बट द डायरेक्शन चेंजेस. सो वेक्टर r bar remains same? No, it doesn't remain same. Is it a constant term then? स्केलर फॉर्म मध्ये आपण सिंपल काय केलं होतं? आर ला डेरिव्हेटिव्ह घेताना डेरिव्हेटिव्हच्या बाहेर घेतलं होतं, कॉन्स्टंट ट्रीट केलं होतं. इथे करता येईल का? असं आपल्याला नाही करता येणार. मग इथे डेरिव्हेटिव्ह घेताना मला प्रॉडक्ट रूल वापरावा लागेल. काय वापरावं लागेल? प्रॉडक्ट रूल. सो dv बाय dt इज इक्वल टू, व्हॉट इज द प्रॉडक्ट रूल ऑफ डेरिव्हेटिव्ह? लिसन व्हेरी केअरफुली. दोन फंक्शनचं प्रॉडक्ट असेल डेरिव्हेटिव्ह घेताना काय करतो आपण? फर्स्ट फंक्शन इंटू डेरिव्हेटिव्ह ऑफ सेकंड. ओके, फक्त असं करताना वेक्टर फॉर्म असेल तर सिक्वेन्स बदलायचा नाही. ओमेगा नंतरच काय आहे? आर आहे. सिक्वेन्स बदलायचा नाही. So first function into derivative of second function, ओके. परंतु सिक्वेन्स काय आधी ओमेगा आहे, सो हे असं लिहायचं, डेरिव्हेटिव्ह ऑफ फर्स्ट इंटू सेकंड फंक्शन. कुठेही मी सिक्वेन्स बदलला का आधी ओमेगा आहे नंतर आर आहे, आधी ओमेगा आहे नंतर आर आहे, कारण क्रॉस प्रॉडक्ट मध्ये सिक्वेन्सला महत्व आहे. ए क्रॉस बी अँड बी क्रॉस ए आर नॉट सेम. Agree? So look at this differentiation with respect to t. Which rule I am using? I am using product rule. Which rule? Product rule. Okay. dv by dt is acceleration. Correct? What is dr by dt? Actually r is position vector. Okay. If this is origin of center of circle is taken as origin, this OA is what? Position vector. हा काय प्रकार आहे? Position vector. So dr by dt is rate of change of position. Rate of change of position means linear velocity. So dr by dt is what? Linear velocity v bar. हा काय प्रकार आहे? v bar. So हे काय येलं? Omega cross v. What it is? Omega cross v. Plus, can you tell me what is d omega by dt? Very good. It is alpha. Angular acceleration. It is angular acceleration. Correct? So linear acceleration comes omega cross v plus alpha cross r. All of you concentrate now. हे ओळखीचं वाटतंय ओमेगा क्रॉस व्ही सगळ्यांना? कुठे मिळालं होतं ओमेगा क्रॉस व्ही? ओमेगा क्रॉस व्ही मीन्स व्हॉट? लाऊड अँड क्लिअर. I can't hear you. What is the meaning of omega cross v? Yesterday's lecture. It is centripetal acceleration. What is this? Centripetal acceleration. काय प्रकार आहे हा? Centripetal acceleration. So this is centripetal acceleration plus what is this? Alpha cross r हा काय प्रकार असतो? बघा इथे 2 मिनिट ह्या डायग्रामकडे लक्ष द्या सगळ्यांनी. हा पार्टिकल आहे, हॉरिझॉन्टल सर्कलमध्ये सर्क्युलर मोशन परफॉर्म करतोय, बरोबर आहे. याचा आर या डायरेक्शनमध्ये, अल्फा कुठल्या डायरेक्शनमध्ये असेल? या डायरेक्शनमध्ये असेल. व्हॉट इज अल्फा क्रॉस आर? बरोबर आहे. ॲक्सिलरेशनचं, हे ॲक्सिलरेशनचं एक्सप्रेशन आहे. एक कॉम्पोनंट काय ॲक्सिलरेशनचा? ओमेगा क्रॉस व्ही इज सेंट्रीपिटल ॲक्सिलरेशन. व्हॉट इज डायरेक्शन ऑफ अल्फा क्रॉस आर? लुक ॲट दिस राईट हँड रूल. काय म्हणतो? दिस शुड बी माय फर्स्ट फिंगर. व्हॉट इज माय फर्स्ट फिंगर? अल्फा. माय सेकंड फिंगर शुड बी अलॉंग आर बार. सो असं करायला पाहिजे, बरोबर आहे. अल्फा आर बार. माय थंब विल इंडिकेट व्हॉट? डायरेक्शन ऑफ अल्फा क्रॉस आर. कशी आहे डायरेक्शन? या फिगरला परपॅन्डिक्युलर. ही फिगर कशी आहे माझी? हॉरिझॉन्टल. सो हे हॉरिझॉन्टल सर्कल जर असेल तर अल्फा क्रॉस आर ची डायरेक्शन कशी असेल? या सर्कलला टँजेन्शियल. कशी असेल? टँजेन्शियल टू सर्कल. हाऊ इट विल बी? टँजेन्शियल टू सर्कल. अँड हेन्स दिस इज कॉल्ड ॲज टँजेन्शियल ॲक्सिलरेशन. काय म्हणतात याला? टँजेन्शियल ॲक्सिलरेशन. व्हॉट वी कॉल दिस? Tangential acceleration. In short, acceleration in circular motion has two components. Acceleration in circular motion has two components: centripetal acceleration and tangential acceleration. Which two components? Centripetal acceleration and tangential acceleration. Centripetal acceleration is responsible for change in direction of velocity. Tangential acceleration velocityच्या दिशेत आहे, and it is responsible for change in magnitude of velocity. I repeat, it is responsible for change in magnitude of velocity. So what we learn? Acceleration in circular motion has how many components? Two components. Centripetal acceleration responsible for change in direction of velocity, and tangential acceleration responsible for change in magnitude of velocity. Now Let us take case of UCM, uniform circular motion. Magnitude of velocity is constant. Angular acceleration is 0. Alpha is 0 means tangential acceleration is also 0. In UCM, alpha 0, therefore tangential acceleration is also 0. So in UCM, only acceleration is centripetal acceleration. युनिफॉर्म सर्क्युलर मोशन मध्ये टँजेन्शियल ॲक्सिलरेशन काय असतं? 0 असतं. पण जनरल नॉन युनिफॉर्म सर्क्युलर मोशन मध्ये ॲक्सिलरेशन विल हॅव 2 कंपोनंट्स. विच 2? Centripetal acceleration and tangential acceleration. Getting it? So if I consider the direction of these two accelerations, centripetal and tangential, these two components are perpendicular to each other. What is their resultant then? कसा काढणार आपण रिझल्टंट यांचा? पहिला वेक्टर काढला AC, त्याच्या एंड पासून दुसरा काढला AT. दिस इज माय रिझल्टंट ॲक्सिलरेशन. ॲग्री ऑर नॉट? What is the relationship in the magnitude of these three then? Very clear. A is equal to under root AC square plus AT square. Agree or not? Centripetal acceleration square plus tangential acceleration square under root is called as linear acceleration. हा जो रिझल्टंट ॲक्सिलरेशन आहे, रेडियसची त्याने किती अँगल केलाय समजा? अल्फा नको, अल्फा शब्द वापरलाय आपण हा अँगल घेऊयात फाय. काय अँगल घेतला मी? हा फाय. आय विल जस्ट ड्रॉ अ बेटर डायग्राम ओव्हर हियर. सी दिस इज माय centripetal acceleration, this is my tangential acceleration, and this is resultant acceleration, and this angle is phi. I am talking about two formulas. First, what is the magnitude of this resultant acceleration? Under root AC square plus AT square. Under root AC square plus AT square. And what is this phi? Tan phi किती है? AT upon AC. What is tan phi? AT upon AC. So phi is what? Tan inverse AT upon AC. What is phi here? Angle made by resultant acceleration with radius. With radius. किंवा with centripetal acceleration. Agree with this? कसा काढणारा? Tan inverse AT upon AC. एक गोष्ट विसरायची नाही. AT काय आहे आणि AC काय आहे? AC सेंट्रिपिटल ॲक्सिलरेशन. कसं काढणार ते? सेंट्रिपिटल ॲक्सिलरेशनचा फॉर्म्युला आपण कालपासून शिकतोय. तो बदलणार आहे का? नाही. व्ही ओमेगा, ओमेगा स्क्वेअर आर आणि व्ही स्क्वेअर बाय आर. टँजेन्शियल ॲक्सिलरेशन, आज जे आपण दुसरं ॲक्सिलरेशन बघितलं, आर अल्फा. व्हॉट इज द मॅग्निट्यूड ऑफ टँजेन्शियल ॲक्सिलरेशन? अल्फा आणि आर हे एकमेकांना परपॅन्डिक्युलर आहेत, हो की नाही? हा आर असा आहे आणि हा अल्फा असा आहे. परपॅन्डिक्युलर आहेत म्हटल्यावर अल्फा क्रॉस आर ची मॅग्निट्यूड काय? आर अल्फा साइन 90. साइन 90 इज 1. सो व्हॉट इज द मॅग्निट्यूड? आर अल्फा. ॲग्री? सो व्हॉट इज टँजेन्शियल ॲक्सिलरेशन? आर अल्फा. व्हॉट इज सेंट्रिपिटल ॲक्सिलरेशन? व्ही स्क्वेअर बाय आर. गेटिंग दिस? सो व्हॉट वी लर्न? In general, linear acceleration in circular motion will have two components. One, along the radius towards the center of circle, called as centripetal acceleration. This acceleration is responsible for change in change in direction of velocity, linear velocity of course. And another component, tangential to the circle, which is responsible for change in magnitude of velocity. Similarly, force can also be divided into two components, centripetal force and tangential force. Centripetal force is along the radius towards the center, tangential force is tangential. Centripetal force doesn't do any work, but tangential force will do work. It will change velocity, it will change kinetic energy, and it will also do work. Centripetal force will never do any work in circular motion. Clear with this? कळतंय सगळ्यांना? UCM is a special case where tangential acceleration is 0. Only acceleration is centripetal acceleration, and the resultant acceleration is vector sum of centripetal and tangential acceleration. These two formulas should be very well understood by you. Agree with this? So write down acceleration in circular motion. Acceleration in circular motion. First point, acceleration in circular motion has two components. Acceleration in circular motion has two components. Centripetal acceleration AC equal to omega cross V, AT equal to alpha cross R. Okay, and our resultant acceleration is sum of AC plus AT. Agree? What are the magnitudes of AC and AT? AC V square by R, V omega or omega square R. हे नवीन नाहीये, फक्त काल आपण UCM बद्दल बोलत होतो आणि त्यामुळे एकच ॲक्सिलरेशन आलं होतं, ते म्हणजे सेंट्रिपिटल. टँजेन्शियल ॲक्सिलरेशन इज व्हॉट? R अल्फा. Draw this neat diagram. This is AC, this is AT, this is resultant acceleration A, this angle is phi. So what is A in magnitude? Under root AC square plus AT square. And what is tan phi? AT upon AC. This is a concept which normally troubles student. Okay, I hope you are very clear regarding this concept. The roles should be very clear in mind. The centripetal acceleration is responsible for change in direction of velocity, and tangential acceleration is responsible for change in magnitude of velocity. Once this is understood, okay, rest of the topic is very, very easy. We will solve a numerical based on this. Okay, it will be far better. A car is taking turn on a circular road of radius 300 meter at a speed meter per second. If the speed of car is increasing at 4 meter per second square, Find linear acceleration of car. Okay, it's a multiple choice question. Okay, it is asked in some CET examination. I don't remember the year exactly. 3 meter per second square, 4 meter per second square, 5 meter per second square and 7 meter per second square. These are the options. Read the question carefully and try to analyze whatever is given to you. Okay, you have written this options. Okay. Whatever is given to you, try to understand. There is a circular road. A car is moving on this circular road. What is the radius of this circular road? 300 meter. Correct? What is the speed of a car? 30 meter per second. So obviously, because car is performing circular motion, there has to be a centripetal acceleration. What is the formula for centripetal acceleration? V square by R. Correct? Car will have centripetal acceleration. Who told me this? Because car is performing circular motion. It cannot perform circular motion without centripetal acceleration. So it is 30 square, that is 900 upon R, that is 300, 3 meter per second square. What is this? 3 meter per second square. Agree? If it is 3 meter per second square, now if car was performing UCM, this would have been the only acceleration. But my car is not performing UCM. Its speed is also increasing at the rate 4 meter per second square. The increase in speed is tangential acceleration. What is that? Tangential acceleration. So car also has tangential acceleration 4 meter per second square. Agree? Increase in speed is what? Tangential acceleration. So in order to find resultant acceleration, I have to add centripetal acceleration and tangential acceleration. So what should be my answer? 3 plus 4, 7? What do you say? 3 plus 4, 7 येईल का? 3 plus 4 इथे 7 नाही येणार, इथे 5 येईल 3 plus 4. का बरं असं विचित्र मॅथ शिकवतोय मी? विचित्र नाहीये. We are adding velocities which are vector quantities. Correct? When we add vectors, it has to be added considering direction. So try to understand my centripetal acceleration and tangential acceleration are perpendicular to each other. Agree or not? So what is the resultant? The resultant acceleration is under root AC square plus AT square. And what will be the answer now? 5 meter per second square. Okay. If you look at the options, it will have 3 written, 4 written, 7 will be there and 5 will also be there. Okay, so there is every care examiner will take. If you are not conceptually clear, you should make mistake. Getting it? Finished with this? Well, this is all about acceleration in circular motion. Okay, now let's move ahead in this chapter. What is the next part that we are going to talk about? Next part is applications of this concept of circular motions, whatever we have discussed so far. Fundamental principles we have already covered. Okay, whatever we are going to learn are applications now. The first application is we will apply this concept for a vehicle taking turn. Okay. See, yesterday also we discussed when a vehicle take a turn along the curved road, even in the previous question we discussed, for a vehicle taking turn along the curved road, there has to be a centripetal acceleration. Means there has to be a centripetal force which produces this acceleration. engine of a car is not capable of providing centripetal force. So in the absence of centripetal force, car will not be able to take turn, it will move tangential to the circle. So how can car take a turn on the curved road? Which force provides the necessary centripetal force? The answer is force of friction. Which force? Force of friction provides necessary centripetal force. Agree or not? Clear है? बरं. आता हा जो फोर्स ऑफ फ्रिक्शन आहे, which friction involved? Kinetic friction or static friction? Many of you may feel there has to be an involvement of kinetic friction because the car is moving, but my dear friend, the car is moving like this. The friction is preventing the motion along the radius perpendicular. Getting it? Is there any motion in this direction? No. So which friction is involved? Static friction is involved. Which friction is involved? Static friction. And there is a maximum force of static friction. There is a limit. What is the maximum force of static friction? The limiting force of static friction is mu into n. आठवत है? N is what? Normal reaction. What is normal reaction? If this is a road, this is my car. Car will exert force mg on the road surface. Road surface will exert normal force on the car. Okay, car is not jumping with any acceleration. That means n has to be equal to mg. So what is the normal reaction for horizontal road surface? Mg. Correct? And the maximum force of friction between the road surface and car is mu s into n. What is n? Mu s into mg. What is mu s? Coefficient of static friction. What is coefficient of static friction? The ratio of limiting force of static friction to normal reaction. What factors coefficient of static friction depends? Nature and material of contact surfaces. What are contact surfaces here? Tires and road. बरोबर आहे? कोण आहे कॉन्टॅक्ट मध्ये? टायर आणि रोड कॉन्टॅक्ट मध्ये. So we are depending on this force to act as a centripetal force. What is this force? Force of friction. This is a maximum value. Force of friction, force of static friction will be either less than this or at most equal to this. It cannot go beyond this. How much centripetal force is required for circular motion of a car? mv square by r. If m is a mass, v is a velocity and r is a radius, how much centripetal force will be required? mv square by r. What is the maximum available frictional force? Mu mg. So obviously the required centripetal force should be less than or at most equal to mu mg. बरोबर आहे की नाही? माझ्याकडे एवढाच मॅक्सिमम फोर्स ऑफ फ्रिक्शन अवेलेबल आहे म्हटल्यावरती सेंट्रिपिटल फोर्स जो रिक्वायर्ड आहे तो सुद्धा कसा पाहिजे? ॲटमोस्ट इतका किंवा याच्यापेक्षा कमी. इफ आय कॅन्सल mm फ्रॉम बोथ साइड्स, what will happen? V should be under root mu rg less than or equal to under root mu rg. Correct? What does this means? This means I should not drive my car at a speed greater than under root mu s into rg. Mu s is what? Coefficient of static friction between tires and road surface. R is what? Radius of the circular road, and g is gravitational acceleration. This is a maximum safe speed with which I can drive a car, okay, on level horizontal curved road. I repeat, this is a maximum velocity with which I can drive a car on level horizontal curved road. What is this velocity? Under root mu rg. हा जो म्यू आहे तो कशावर डिपेंड आहे? कशावर डिपेंड आहे म्यू? नेचर अँड मटेरियल ऑफ कॉन्टॅक्ट सर्फेसेस. म्हणजे टायर आणि रोड यांच्या कंडिशनवर तो म्यू अवलंबून आहे. जर माझे टायर्स घासून गुळगुळीत झालेले असतील, जुने टायर्स असतील, तर काय होईल? म्यू विल बी स्मॉलर. So such a car has to be drawn very slowly, okay, or it is in more danger of skidding or slipping. Getting it? So my tire should be new. New means what? New tires means there are enough roughness. नवीन टायर जर तुम्ही बघितले आणि वापरलेले टायर्स, काय फरक असतो? नवीन टायर रफ असतात. ओके, आपले शूज सुद्धा नवीन असताना त्याचे जे सोल आहेत ते कसे असतात? रफ असतात. ओके, वापरल्यावरती ते काय होतात? स्मूथ होतात. बरोबर आहे? गेटिंग दिस? सो द फ्रिक्शन कोइफिशियंट डिपेंड्स ऑन द नेचर ऑफ टायर्स. Agree with this? It also depends on the nature of road surface. Suppose there is a wetness on the road, पाऊस पडला, वाळू सांडली, ऑइल सांडलं, what will happen? The road surface will become smooth, the coefficient of friction will decrease. So क्लासला येताना ज्या रोडवरनं तुम्ही बिंदास सायकल वळवली होती, ओके, 30 मीटर पर सेकंड स्पीडनं, जाताना जर तिथे पाऊस पडून गेला असेल आणि त्या स्पीडनं जायचा प्रयत्न केला, काय होईल? Every chance that the cycle will skid. Okay, it will not be able to perform circular motion at the required speed. Agree or not? कळते? So write down in your notebook. It's a homework question. Derive the expression for maximum safe speed for a vehicle taking turn on level horizontal road. ओके, काय फॉर्म्युला येणार आहे हा? V इक्वल टू अंडर रूट म्यू एस आर जी. करेक्ट? व्हॉट विल बी द फॉर्म्युला? अंडर रूट म्यू एस आर जी. सी नाउ, डिपेंडिंग ऑन द फ्रिक्शन फॉर द सेफ्टी ऑफ व्हेइकल इज अ व्हेरी डेंजरस थिंग. वाय? जस्ट नाउ वी डिस्कस दैट this maximum safe velocity depends on mu s, which depends on tire and road condition. Okay, you can take care of your tires, but you cannot take care of road. Can you? Okay, can you ensure that the express highway going from Pune to Bombay will not have any oil falling on it at the curves? Okay, you cannot assume that. So, depending on the friction is very dangerous for the safety of a vehicle. A. B. If you depend on the friction, because of the friction there is lots of wear and tear of a tire. सो अशा हाय स्पीडनं जर आपण कर्व रोडवरती ट्रॅव्हलिंग केलं तर टायरचं विअर अँड टिअर पण खूप होतं, फ्रिक्शन पण खूप होतं कर्वला. सो देर शुड बी सम मेथड बाय विच वी कॅन एन्श्युअर द सेफ्टी ऑफ अ व्हेकल अँड वी डोंट हॅव टू डिपेंड ऑन friction, because frictional force is not reliable. What is the problem with frictional force? It is not reliable. It will change with the road surface and the tire conditions. And B, the friction causes wear and tear of tires. Okay, so it's not economical also. So we should have some method by which the safety will be ensured and we don't have to depend on friction. The method that is used along the highways for the safety of a vehicle is called as banking of roads. काय म्हणतात त्याला? Banking of roads. If you look at the roads along the curve, they are not horizontal, but they are inclined to horizontal at certain angles. If you see the bicycle race, ऑलिम्पिक मध्ये जर तर बायसिकलच्या रेसचा ट्रॅक बघितला किंवा फॉर्म्युला 1च्या रेस तुम्ही टीव्हीवर बघत असाल आणि त्याचे ट्रॅक्स बघितले अलॉंग द कर्व, ते ट्रॅक्स हॉरिझॉन्टल नसतात, तर ते हॉरिझॉन्टलशी सर्टन अँगल करतात. दिस प्रोसेस इज कॉल्ड ॲज बँकिंग ऑफ रोड. व्हॉट हॅपन्स बिकॉज ऑफ द बँकिंग ऑफ रोड? वी डोंट हॅव टू डिपेंड टू मच ऑन फ्रिक्शन फॉर सेफ्टी ऑफ अ व्हेकल. नाउ हाऊ? There is some mathematical relationship, some formula to be derived that we will do in our next lecture, because it's a big part and very important question will be coming in the examination for 4 marks related with banking of roads. Okay, what is banking of road though? the road surface along the curve is not kept horizontal, but it is kept inclined to horizontal at certain angle. This process is called as banking of road. How it helps or how it ensures the safety of a vehicle, that we are going to discuss in our next session. ॲग्री विथ दिस? इथपर्यंत कळालंय सगळ्यांना? आता आपण काय करूयात, आत्तापर्यंतच्या गोष्टी ज्या झाल्या त्याच्यावरती काही न्यूमेरिकल्स सॉल्व्ह करू. ओके, सो टेक डाऊन द न्यूमेरिकल्स. ओके, आत्तापर्यंत आपण जो काही चॅप्टर बघितला आहे सर्क्युलर मोशन, त्याच्यामध्ये रँडम न्यूमेरिकल्स मी घेतोय. ओके, कुठल्याही सिक्वेन्स यामध्ये फॉलो करत नाही आहोत. ठीक आहे. टेक दिस क्वेश्चन नंबर 1. कॅल्क्युलेट द अँग्युलर वेलॉसिटी. कॅल्क्युलेट द अँग्युलर वेलॉसिटी अँड लिनियर वेलॉसिटी of a tip of minute hand of length 10 centimeter. Okay, read the question carefully. एवढंच दिलंय. घड्याळाचा जो मिनिट काटा आहे त्याचं जे टोक आहे, टिप आहे, त्याची अँग्युलर वेलॉसिटी विचारली आहे आणि त्या टिपची लिनियर वेलॉसिटी विचारली आहे. ठीक आहे, करा, विचार करा आणि सॉल्व करा. रेडियस इज गिवन. मिनिट हँड बद्दल काय माहिती आहे तुम्हाला? व्हॉट इज 60 सेकंद? 60 सेकंद इज 1 minute. So what? Time taken for complete revolution 60 seconds, 1 minute. I don't know. मिनिट हँड तुमच्या घड्याळात आहे का? मिनिट हँड आहे का? आहे. बरोबर आहे. त्याला एक फेरा कंप्लीट करायला किती वेळ लागतो? 60 मिनिट्स लागतात. किती वेळ लागतो? 1 तास लागतो. 1 मिनिट लागतो का? असं नाही करत तो. 1 मिनिट कोणाला लागतो? सेकंड हँडला लागतो. ओके, सो फॉर अ मिनिट हँड द टाइम रिक्वायर्ड फॉर कंप्लीटिंग 1 रिव्होल्यूशन इज व्हॉट? 1 hour or 60 minutes. It is time period, isn't it? So what is time period for minute hand? It is 60 minutes. In seconds it is 3600 second, isn't it? What is the time period of minute hand? 3600 second. Agree? बरं, मस्त. मग आता काय विचारलंय आपल्याला? अँग्युलर वेलॉसिटी. सो कॅन यू कॅल्क्युलेट अँग्युलर वेलॉसिटी नाव? What is omega? Angular velocity is how much? Which formula? T is equal to 2 pi upon omega, or omega is equal to 2 pi upon T. So 2 pi upon T. Don't struggle with these easy calculations now. Two ने divide केलं 1800, which can be 1.8 into 10 raised to 3. So this can be written as omega equal to 3.14 upon 1.8. This 10 raised to 3, if it goes in the numerator, it will be 10 raised to minus 3. 18 न डिवाइड करता येतं. कोणाला येतं आहे की नाही. What should be the unit of this omega? Exactly, radian per second. Correct? So it will be 1.75 into 10 raised to minus 3 radian per second. No one can do calculations for you. Okay, you have to do your own calculations, and that will happen with lots of practice. If you are not willing to do any practice, even next March, the situation will be same. This is angular velocity. What is asked next? Linear velocity. What is linear velocity? R into omega. What is R? 10 centimeter means 0.1 meter. Omega is already there. So what will happen? 1.75 into 10 raised to minus 2, not 4. No, minus 4 is barobar hai. Meter per second, correct? 0.1 न मल्टिप्लाय करायचं म्हणजे 10 raised to minus 1. So 1.75 into 10 raised to minus 4 meter per second. This is required linear velocity. I hope all of you realize this, understand this. Okay, if the same question is asked for second hand, then what is time period for second hand? 60 seconds. Correct? You can all do this calculation yourself. Okay, next question now. Propeller blades in aeroplane are 2 meter long. Propeller, P-R-O-P-E-L-L-E-R, propeller blades in aeroplane are 2 meter long. There are two questions. A, when propeller is rotating at 1800 revolutions per minute, compute the tangential velocity of tip of the blade. Compute the tangential velocity of tip of the blade. B. Okay, second question B. What is the tangential velocity? What is the tangential velocity at a point on a blade midway between tip and axis? Midway between tip and axis. Okay. Okay, suppose this is a propeller. Okay, पंखा आहे त्या एरोप्लेनचा आणि तो अशा प्रकारे रोटेट होतोय 1800 RPM ला. बरोबर आहे. त्या ब्लेडची ॲक्सिस पासूनची जी लेंथ आहे ते दिलेली आहे. ती किती आहे? 2 मीटर. So radius is 2 meter. Frequency is given 1800 RPM. Correct? There are two questions. Linear velocity of tip of a blade and linear velocity of midpoint. Do your own calculations. Make it fast. So what you will do with 1800 RPM at first? Divide by 60 and make it into hertz. So frequency will be, correct, 30 hertz. Okay. So what we can find out from n? We can find out omega, angular velocity. What is the relationship between n and omega? Omega equal to dash dash 2 pi n. अभ्यास करा, पुस्तक घ्या. What is omega? 2 pi n. So angular velocity is 2 pi n. Correct, this is angular velocity. It was not the question. Now the real question is, A, what is the linear velocity of this tip? What is the formula for linear velocity? R into omega. What is linear velocity of a tip? R into omega. Agree? So this is omega, R is 2 meter. Okay, you can easily do the calculations. This was question A. What is question B? Linear velocity of point midway between the axis and the tip. What is the difference? See, all the particles on this blade have same angular velocity. Remember, all of them have same angular velocity, but the radius of their circular motions are different. So what is the radius for this point? 1 meter. So what will happen here? The linear velocity will be R into omega, or let's say R dash into omega. What is R dash here? 1 meter. So 1 into 188.4, that is 188.4 meter per second. This will be the required answer. So what we learn from this, for a rotating body, all points on a body will have same angular velocity. All points on a body will have same angular velocity. What will be the difference then? The radius of circular orbits will be different, hence the linear velocities will be different. Next question. Take this question. A coin is kept at a distance 10 centimeter from the center of turntable of radius 1 meter. A coin is kept at a distance of 10 centimeter from the center of turntable of radius 1 meter, it just begins to slip when turntable rotates at 120 rpm. rpm. Calculate coefficient of static friction between coin and turntable. This is an interesting question. Read this question very carefully. Okay, circular turntable. A turntable means a table which is capable of rotating, turning. Correct? The radius of that turntable is given to you. What is the radius? 1 meter is the radius. Okay, on this table there is a coin which is kept at 10 centimeter from the center. Now as this turntable starts rotating, when the speed becomes 120 rpm, what happens? The coin starts slipping. Slipping म्हणजे तो बाहेर ढकलला जातो, झोपतो नाही. Sleeping. ओके, म्हणजे टर्न टेबलने झोका दिलाय कॉइनला असं अर्थाने नाही. That is more favored reaction because the lecture is already 1 hour 15 minutes already passed. Okay, so that sleeping may be more comfortable for you. Anyway, look at this. See, if there is a circular turntable and it starts rotating, if I take this turntable, okay, I don't have coins, so